Hello everyone, welcome back to my channel. Today we're starting a 3-part mini-series videos on sleep quality and academic performance. This series is based on a real student project I mentored, and for teaching purposes, we're working with a simulated dataset that mirrors real student survey data rather than just working with the original data. In part 1, we're going to set up and run a hierarchical multiple regression in SPSS. In part 2, we're going to see if the assumptions are met. And in part 3, we're going to see how to report the results. So by the end of this video, you'll know how to organize predictors into blocks, run the regression, and see whether sleep quality really predicts GPA above and beyond demographic and lifestyle factors. So this is a predictive cross-sectional study, and our research question is, does sleep quality predict GPA after accounting for gender, academic major, and caffeine use? The dataset has about 100 undergraduates from 3 universities. Again, the data are simulated, but they reflect realistic patterns you should see in health psychology and education research. So here are the variables in our analysis. GPA is the dependent variable, which is self-reported by students. PSQI, this is our measurement of sleep quality. The higher PSQI, the worse sleep quality. And gender, we coded them like 0 for males and 1 for females. Major is the categorical variable, like art, science, or engineering. We'll need to dummy code this variable in SPSS, and I'll explain what the dummy code is in the next few minutes. And caffeine use is also a categorical variable, so we need to dummy code this one as well, and the same logic goes for it too. Here our plan is to use hierarchical regression in 3 steps. Step 1, gender plus major and their effect on GPA. Step 2, add PSQI above gender and major. Step 3, add caffeine use above PSQI, gender, and major. But let's see why this method. Why use hierarchical regression instead of just throwing everything in at once? Because we want to see if sleep quality adds predictive value above and beyond the basics. As I said, in Model 1, we test whether demographics, gender, and major explain GPA. In Model 2, we add PSQI, and if the R-squared increase significantly. And in Model 3, we add caffeine use and see if it contributes further. This is how the technique works. Any change in R-squared tells us exactly how much extra prediction each block gives. So now that we're done with the introduction, let's go into SPSS and set this up. You see in data view, each row is 1 student. And in variable view, check the setup. GPA and PSQI score are scale variables. Gender is numeric with labels 0 for males and 1 for females. Major is categorical with 3 subcategories that each of them has 1 label. 1 is for science, 2 is for engineering, and 3 for arts. The caffeine use is also categorical with values of 1, 2, and 3, which are labels of 1 for low, 2 for moderate, and 3 for high. So, as I said, before building the model, we need to transform the categorical variables of major and caffeine use, because right now we can't make a use of them. To include major correctly, we need dummy variables. Dummy variables are numerical variables used in statistical analysis to represent categorical data, typically by taking values of 0 and 1. So let's do it. Go to transform, recode into different variables. And in the window that pops up, move major into the box, and in name box, name the new variable. So let's start with science and name it major underscore science. Then click on old and new values. Here, under old value, set old to 1, and under new value, set new to 1, 2. Now click on add, and again this time repeat this process for 2 or 3, but this time assign them to 0, because the only subcategory that we care about here is science. And continue, click change and OK. So repeat this process for major engineering. Go to transform Recode into different variable. Remember to put back major into the list so you can choose it. This time we care about the subcategory of engineering. We want to make a dummy variable for major engineering. So the code that was related to engineering in the original major variable was 2. So we assign 2 to 1 this time, and 1 and 3 to 0. Continue, change, and OK. So you may ask now, should we do the same for arts too and make a dummy variable for major arts too? And I would say no, because arts will automatically become the reference group, so it doesn't get a dummy. And now we have 2 variables. You see in the data view the columns of these 2 new dummy variables. And you see the one student whose major is engineering. The value assigned to it in major engineering variable is 1. And for the same student, the major science variable is 0. So that's what we wanted. Now we repeat the same process for caffeine use. We wanted to make 2 dummy variables, one for caffeine low and the other one for caffeine moderate. We don't care about caffeine high because it will automatically become the reference group. Under old, write 1, and also under new, write 1, 2. And like the major variable for 2 and 3, we assign them to 0 because we want to make a dummy variable for caffeine low. And anything other than that will get a 0. Then make caffeine moderate variable. Remember to put them back into the list. Under the old one, this time write 2, because in the original variable of caffeine use, the label that was assigned to caffeine moderate was 2. So now we're going to change it to 1, and anything other than caffeine moderate will get a 0. So now see, we have 4 new dummy variables. Now that we're done with the dummy variables, let's go ahead and build the model. Go to Analyze, Regression, Linear, move GPA into dependent box. So now for block 1, enter gender, major underscore science, and major underscore engineering. This sets up the baseline model, which includes demographics only, with arts as the reference for major. Click Next. In block 2, add PSQI to the independence box. This lets us see how much additional variance of GPA is explained by sleep quality above and beyond gender and major. Click Next. For block 3, add the caffeine dummy variables. This step tests whether caffeine use adds any predictive power beyond demographics and sleep. Leave method as enter. Now click on Statistics and check Estimates, Model Fit, R-squared change. This one is crucial. Confidence intervals, multicollinearity diagnostics, and descriptives, and part and partial correlations. Then click OK to run the regression. So here are the results. We have the model summary table. Here is the first model where GPA is predicted just from gender and major. You see the R-squared is 0.026, meaning that demographics of gender and major explain only 2.6% of the variance in GPA. The p-value for it is 0.474, so none of the predictors are significant. But let's go down to see the coefficient table and results for Model 1. You see gender's coefficient here is negative 0.007, and the p-value for it is 0.921. So basically it tells us that there is no effect of gender. Also, the p-value for major science vs arts is 0.130, which is not significant. And the p-value for major engineering vs arts is 0.212, which is also not significant. So we conclude that in Block 1, gender and major don't predict GPA. Now, let's look at what happens when we add a sleep quality in Block 2. Scroll up to the model summary table. You see R-squared jumps to 0.357, which means that the model now explains 35.7% of GPA variance. And the R-squared change is about 0.33, and also the p-value is less than 0.001. But let's again see the coefficients. So scroll down to the coefficient. The PSQI coefficient, or sleep quality coefficient, is negative 0.074, and p-value is less than 0.001, which show that worse sleep quality predicts lower GPA. Here I'd like you to notice that after adding PSQI, gender and major coefficients shrink even further, and it clearly tells us that they are non-significant. That means once we control for sleep, demographics don't explain GPA. Finally, in Block 3, we add caffeine use as a categorical predictor. You see in the model table, R-squared stays at 0.357, meaning that caffeine adds nothing to the prediction. And both coefficients are non-significant, as you can see. For moderate vs high, it is 0.005 with p-value of 0.95. And for low vs high, it is 0.019 with p-value of 0.81. For Model 3, we saw that after controlling for sleep and demographics, caffeine category doesn't help explain GPA in this dataset. So here's the big picture from the coefficients for all models. A sleep quality, or PSQI, is a strong and significant negative predictor of GPA, meaning that the higher PSQI results in the poorer GPA, while gender, major, and caffeine use has no effect. So in this study, the only consistent predictor of GPA is sleep quality. Of course, before trusting these results, we need to check regression assumptions like linearity and normality of residuals, homoscedasticity, and multicollinearity. And these are things we'll go deeper into in part 2. So I want you to see what we did and what we'll cover in the next 2 videos one more time. In this video, we learned how to build a model step by step in SPSS. We created dummy variables for major and caffeine use. Then we ran a hierarchical regression in 3 blocks. And finally, sleep quality emerged as the only meaningful predictor of GPA. In the second video, or the second part, we will check the regression assumptions and reliability of our results. In the third and final video, You'll see a wrap-up, visualization, and how to report the results. If you found this video helpful, don't forget to like, subscribe to my channel, and hit the bell icon. Thanks for watching, and I'll see you in the next videos.